All right, this is Susan Poss again with Spartanburg Community College. I'm still in section 9.4. We just did, in the previous video, a monomial times a binomial. We did a distributive process. And we're starting this time multiplying a binomial times a binomial. And I hope you remember something called first, outer, inner, and last. So that is the technique that I'm going to use here. And I'm thinking there's probably one thing I need to say here. There's a 1 sitting out in front of that square root of 7. Understood? All right, so let's do first times first. I suppose I should put the 1 in there too, shouldn't I? So that's first times first. Now let's do outer. So I see a positive 3 square root of 7 times 3. Then let's do inner, and I see a negative 2 times 1 times the square root of 7. And then let's do last times last, and I see a negative 6. So this is the result of first times first. This is the result of the outside terms. This is the result of the inside terms. And this is the result of multiplying the last terms. Okay, so again, I hope you see 1, 2, 3, 4 terms. All right, so we already talked about what do you do when you have this square root of 7 times square root of 7. 1 times 3 is 3. Square root of 7 times the square root of 7 is 7. So this first term is going to end up being 21. All right, on the second term, this 3 is not under the radical. So I will multiply the 3 that's not under the radical by the other 3 that is not under the radical. And that next term is going to be 9 times the square root of 7. Okay? And then here, I'm going to multiply the 2 and the 1 to get negative 2 times the square root of 7. And then here on the end is just, I've already finished, and that gave me a negative 6. So I still have 4 terms. 1, 2, 3, 4. And of those 4 terms, these 2 are alike, and these 2 are alike. All right, so let me do the numeric part first. 21 subtract 6 is positive 15. And then remember, these numbers out in front are the ones that combine, and the radical just trails along on the end. So there's my final answer. I can't go any further because the square root of 7 does not have a match over there with the 15. All right, so this next one is very similar. It's a binomial squared. And what that means is you write this binomial down twice. As a multiplier, that's what the exponent tells you. Use the base as a multiplier, in this case 2 times. And then I'm going to do the first, outer, inner, last process. So I have the square root of 6 times the square root of 6 for the first, plus I have the square root of 6 times the square root of 2 for the outside. I have the square root of 6 times the square root of 2 for the inside, and I have the square root of 2 times the square root of 2 for the last times last. So again, whoops, not the color I want. 1, 2, 3, 4 terms. All right, let's see what we can do. Square root of 6 times the square root of 6 is 6. I'm going to go ahead and split that 6 up. Same thing here. And then square root of 2 times the square root of 2 is 2. All right, so while I'm writing this down, I'm going to go ahead and I'm going to combine these like terms, so it's just not quite so much for me to have to write. So there's an 8 coming out of all that. And when you look at this, I'll go ahead and write all this down. Again, you could do this in your head without having to write all this down. Remember that these square root of 2 times square root of 2 is going to give you 2. And you generally write the thing that's out from under the radical in the front. And let the radical be the caboose, bringing up the end of the expression. And I see one final thing I can do here. These two terms both have exactly the same radicand with the same index. So these 2's are going to add, and that square root of 3 is going to hang out there on the end. And that looks like our final answer. Good place to quit on this video.